Welcome to Huawei Middle Eastern Innovation Lab. From previous video, we have already shown how to bring WAN and LAN devices online. Starting from this video, we're going to focus on the overlay services. This is also the beauty of SD-WAN solution compared with traditional WAN solution, which is called application optimization. Move on to the next slide. As you can see, we have many topics in this session. So we're going to go through all the test cases, in detail. So you can also see from the right topology diagram, there's a little different from the previous video. So we add one more server, which is called WAN emulator. So the emulator, it is to simulate the link quality, such as the packet loss, delay, jitter, this kind of issues, So the reason I add this server, because we are going to test the intelligent link switchover. So we need some tool to break the link quality. So as you can see, our WAN emulator is deployed between the AR3 and internet link. So remember that we're going to use AR3 to test the intelligent link switchover test cases. So let's move on to the live environment. Go back to our SDN-Campus homepage. So from this video, from application optimization test cases, I will start from the policy, traffic policy. So this is the same features as. Remember that previously we followed the navigation wizard for traffic policy. So because we need to identify the application group first. So that's the reason I want to go back to show the details. So firstly, you need to identify the applications. Then we will create a traffic policy and define the specific applications. So now we're going to use two applications for the first test case called application-based traffic steering. So firstly, let me create an application called HTTP. Because this is HTTP, it is easy to simulate the test cases. We can just use a very small HTTP server, and we'll search the HTTP application from our signature database. We will select HTTP and HTTP_download. These two applications. As you can see here, we have the SA signature database. So there is a drop-down menu here. You can choose. You have two options: 500 plus and 6,000 plus. As I mentioned previously, our Huawei SD-Campus support up to 6,000 plus application types. So this support for the high-level model routers. For low-level model router, so we support up to 500 plus. So actually 500 is very enough for the common applications. Just click OK. So a new application group has been created. Let me create another one for FTP. We will use FTP. Search FTP. Done. And from the policy, you can see we have the application group and the customized application. We also have the predefined application, which means you don't have to define applications. The applications can be identified automatically. The reason why I define the application here, because I need to implement these two applications for the traffic policy purpose. Let me go back to the traffic policy. You can see this is only for overlay network. Intelligent traffic steering. We don't have any traffic policy here. So firstly, we need to go click inside the policy template management, and we need to create a policy classifier template for HTTP And so this classifier template, you can see you can restrict any traffic, the specific HTTP traffic, allow this traffic from the source IP or source port to the destination IP destination port, okay? Or you can also identify the DSCP, okay, and protocol. So we don't need to make the, we just want to make the demo as simple as possible. So just need to implement the application that we already defined from the application group, okay? This is for HTTP. Click OK, and we will identify another FTP. Select FTP, click OK. Okay, it's done, and then we go back to the traffic policy, create HTTP traffic, and then implement the traffic classifier template. We set up first priority, okay, for HTTP. And from the second portion, you can see this is related to the switchover condition. So the switchover condition is based on the link quality, delay, jitter, and the packet loss. We have already have the different default identification definitions here. For voice, we give the default value 150 millisecond for delay. If it's greater than 150 second, which means the switchover will automatically happen. Okay. And for real-time video, low latency data, bounded. You can also customize the value, the threshold value for each parameters. Okay, we just keep the default setting. We don't want to change anything. The third portion is called transport network priority. Okay, remember that I explained in previous video what is the definition of transport network. So this is a new definitions in SD-WAN solution, which means if you have two physical uplinks, you will have two transport network. And we also call that TN. Okay, so for HTTP traffic, I will give two uplinks. Okay, because for each site we have two uplinks. So the first priority for HTTP traffic, we'll select internet. Second priority, we'll select MPLS. Okay, and we keep the traffic behavior for preference. If you want to test the load balance, you need to select here, this one. Okay, and the other will leave as default. Now a new traffic policy has been created. We need to assign the specific sites for the new policy. So for this demo, we're going to assign the site 1 and site 2. Okay. And we'll create another traffic policy for FTP. Implement FTP traffic classifier. For FTP, the first priority will be MPLS. The second priority, I will set internet, so which is opposite to HTTP traffic. Okay, just want to make some differences, so we can compare the two traffic in the live environment in a one optimization. We click OK, and we also need to assign the site for FTP traffic, same as HTTP, site 1 and site 2. So after you create the two traffic policy, you need to click commit. Okay. Now you can see the two policy has been committed. So which means from now this two policy has been pushed from controller to devices. Okay, to site 1 and site 2 access router. Okay, so let's double confirm whether the policy has been pushed successfully or not. For site 1, we have AR1-1 and AR1-2. Okay, so we expand AR1-1, which is under intelligent policy-based routing. Click for detail. As you can see, HTTP FTP has been created. Okay, just now, and also AR1-2 success, AR2 success. Okay, now let's open some test PC. Okay, from site 1 and site 2. I have already opened that. So we're going to first use two application servers, HTTP server and FTP servers for test purpose from site 1. We have a small HTTP server called HFS. Okay, so automatically define the IP address for site 1, PC 1. And we'll also open another FTP server. Okay, FTP, and make sure we select the correct folder. Okay, start. Okay, and also for the HFS, for the HTTP server, we need to just drag this file, same file, to the HTTP server. Okay, come back to the site to PC2. Okay, so what is my IP? My IP is 13. Okay, 12.1.1.45. This is used for the RTP. Okay. And the destination for site 1 PC 1 will be the 11.1.1.122. Okay, I'm able to ping 11.1.1.122. Now I will open the HTTP browser 11. Okay, I'm able to open for FTP client. So this is a username and password that I set on FTP server. Okay, same file. I'm trying to download the same file from FTP server and HTTP server. Okay, as you can see, the HTTP and the FTP we download the same file with a similar speed. Okay, so this is a correct download speed, because remember that we already set up the bandwidth for both HTTP, for both internet and MPLS link to 10 megabits per second. Okay, downlink and uplink. Okay, so assume that this bandwidth is provided by service provider. Okay, so there's no any issues. How to confirm the traffic policy, okay, which is correctly assigned to the router, okay, and whether the applications has been identified correctly. So let me open AMP remote to access the router. Okay, so we just need to open the router AR1-1, because from AR1-1, so the traffic is overly uplinks. So we download from site to PC. We download on site to PC from site 1, okay, server to site 2. So we will use the command display smart SPR all. Okay, this command will show all the overlay traffic. Okay, so you just need to check the remote side site to PC2. What is overlay IP address from that PC? So that PC should be the 12.1.1.1, this subnet. Okay, so this is meaning this subnet is going through the site 21 and VPN ID 4. Okay, so this is the VRF name for overlay network. Okay, so the site ID will be automatically generated once the BGP EVPN has been established. So we will use this command followed by the destination site 21 and the VPN index 4. Okay, the last command will be verbose. As you can see from this output will be the HTTP traffic and FTP traffic. By using this command, we can check the exact traffic coming through the HTTP. Okay, so you can see the HTTP. Okay, the speed for HTTP will be you just need to check this line, application upper band. Okay, this is meaning from site 1, our traffic is the uplink, okay, overlay uplink. So the speed is around 9.98 megabits per second. So this is a correct speed, close to 10 megabits per second. And this is related to the connection ID 5. And for another one, connection ID 3. There's no any traffic. Okay, so why we have two connection ID? That's because the HTTP traffic have two options: first internet, second MPLS. Okay, so I believe this is for internet link because we set up the traffic policy, allow HTTP going through the internet and allow FTP go through the MPLS. Okay, and we move to the, remember that 5 should be the internet, and the FTP, okay, should go through the MPLS. So you can see connection ID 3, the speed is around almost 10 megabits per second, and for connection 5 there's no any speed. So how to check the connection ID, okay, to confirm which one is internet and which one is MPLS? We just need to use the command display EVPN connection. Okay, we can get this output. So there are totally 6 EVPN connection. Okay, so because for site 1 we are the hub, and each site have 2 uplinks. So you can see this IP, this is my internet public IP address for site 1, the source IP. This is my MPLS link, okay, 36.250 on site 1. Internet, MPLS, internet, MPLS. The destination IP is different. So 37.250, 38.250 are the site 2. So this is site 3 and this one is site 4. Okay, so we download traffic from site 2, okay, on site 2. So it should be the 37 and 38. Okay, so you can see the connection. This column will be the connection ID. So connection 5, connection ID 5 should be internet. Connection ID 3 should be MPLS. Okay, which means this is a correct. The traffic FTP only going through the MPLS. Okay. All right, let's come back to the SDN-Campus. So we have already confirmed from command line prompt that the traffic is going through correctly. And how can we monitor the WAN traffic from Amazon SDN-Campus? Okay, you can click the monitoring drop-down menu, and which is under the site. So we just need to check the site 1 for overlay uplink. Remember that we download the traffic from site 1 to site 2. Okay, so we have 4 devices on site 1, and we move a little bit down. So for site 1 we have dual gateway 2 access router. Okay, you can just check the status of the router, CPU, memory, temperature. As you can see, we have already seen some traffic starting from this time. Okay, the traffic is dramatically going up. Normally, the report data to controller is real time, but the controller also need to spend some time to analyze the data and generate the chart. Okay, this time normally should be around 5 to 10 minutes. Okay, so you just need to wait several minutes. So currently we cannot see any uplink overlay. After 5 minutes you should be able to see, I believe. And if you want to see the real-time data, so you can click the one link for the past 1 hour, and then make sure you enable this real-time monitoring. Okay, so the throughput trend, you see the latest time same as my time, because this is a 10:50, okay, 55. This is a Dubai time. I'm currently living in Saudi time. As you can see, the latest time is actually the real time. You can see the internet and MPLS almost close to 10 megabits per second. Okay, because SD-WAN traffic will the datagram, the frame will be encapsulated by some header. So that's the reason you cannot see the full data, okay, from here. Okay, we can also move to the bottom part. You should be able to see the delay, jitter, and packet loss. If there are any issues happened, you can also monitor from this chart. Okay, and we come back to the overview. Let's check whether the internet and then okay, still not come. Just wait several minutes. So you can see after refresh this monitor, and we can see now the HTTP traffic is close to 9 megabits per second. And for FTP, it's also the same speed. You can see the FTP is going to the MPS and HTTP is going to internet. Okay. So the 8.95 is the actual data RAM, except the header of the SD-WAN tunnel. Okay. So we will not show the SD-WAN, the header to the SD-WAN tunnel in this monitoring chart.